Okay, so seventh grade, this is Unit 1, Lesson 8. We're starting on page, looks like 69. And this one, this very first one here, I'm going to mark it. And I will check Monday, and this one's worth a stick. So it says two cities. They don't name them, but they're 243 miles apart. It takes a train 4 hours to travel between the two cities at a constant speed. And a car travels between the two cities at a constant speed of 65 miles per hour. Which is traveling faster, the car or the train? And I'll help you out with the train here just a little bit. It takes the train 4 hours. So the first thing you're going to do is divide 243. You're going to divide that by 4, and you'll get an answer. And then you can compare that to the car at traveling 65 miles per hour. So I'm kind of helping you out with that. So I'm going to randomly just pull names on Monday, and we'll see if anybody got it. All right, down at the bottom here, page 69. It says the driver is traveling at a constant speed on Interstate 90 outside of Chicago. If she traveled from point A to point B in 8 minutes, did she obey the speed limit of 55 miles per hour? And I'm going to help you out with this one a little bit too. I'm going to move this over. And when I measured it, we're going from A to B here. And you can see it in the video. I used centimeters. And so it's about 2 centimeters from B to right about there, which I just marked with a red dot. And I had a total of about 10 centimeters. But what's important is you want to look at the scale, and all maps have what's called a scale. How many of you are familiar with the scale on a map? Do you guys know how those work? Not very many of you. Okay, so you can see here that from 0 to this point right here is 1 mile, and then from 1 to right here would be 2 miles. So you want to, you could grab your protractor, and see that doesn't work quite well. I mean, it's not quite 2.5 centimeters. So you could try inches. Is this 1 inch? Okay, let me zoom in a little bit. Shh. They're all grabbing protractors. You can see 1 inch right here. And again, it doesn't quite get to 2. So here's something that you'll want to do. You get yourself a piece of scratch paper. This is what I would do. Maybe it's a sticky note. Whatever you want to use. Watch what I do here. This first mark is where 1 would be, and this would be 2. I'm going to put a 2 right here. That's 2 miles. Then I'm going to lift it up and move it over. And so to here would be 4 miles. And then to here would be 8 miles. And you could use something like this to measure distances. And we're going to do something else similar in just a moment. So, where was I here? So I'm going to say the distance just to help you guys out here. Gosh, I'm running out of room on my desk here. Is about 8.5 miles from A to B. So write that down. 8.5 miles from A to B. Yeah. Yeah, I don't, not looking for the answer. If you know the answer already, that's great. But again, that map is referencing the question on the bottom of page 69. So you can say it's about, and that little squiggly line means about 8.5 miles. All right. So just so we're all working from the same thing. So I want to see if you can figure that one out. And again, I'm going to make this one also worth a stick. All right, and see what kind of answers we get. Let's look at number 2 here real quick. It says a helicopter is traveling from A to B in 8 minutes. Did the helicopter travel faster or slower than the driver? And the driver, let's see here. Yes.
So the driver is the one from 8.2 because, so let's see how it's not a different one. See how it's not 8.1 or 8.3. It's the same one because it's question 2 for 8.2.
Okay, thank you for pointing that out.
Yep.
So it is from the same one. It's going to be the driver here. I do want to point this out to you guys. Think about it this way. A helicopter, it's not going to be following the roads. It's going to be a straight line from A to B. So as far as miles, who's traveling further, the car or the helicopter? The car is traveling further. So if the times are the same, who's traveling faster? The car. All right. So keep that in mind as you work through that. Let's look at 8.3. How am I doing on time here? 8.3. Cyclist is going at a constant speed of 15 miles per hour. At this speed, how long would it take the cyclist to ride from Garden City to Dodge City, Kansas? Here we are. Garden City to Dodge City, Kansas. And there's a scale. And I had shown you guys earlier a way to do that. And I'm going to do another one. If I can find my little pencil. I don't see it. Oh, there it is. And so from the edge to right here is 4 miles. And you guys could even just use scratch paper for this. So I'm going to move that all the way over to the 0. And it's going to be another 4 miles, which would make it 8, 12, 16. And I'll stop at 20. There's 20 miles right there. So now I'm going to do a quick rough measurement. Now I know there's going to be curves in the road, and you can even see on the map it's not perfectly straight, but this is an approximate. So from here to about right there is 20 miles. And then right there, whoops. Right there is another 20 miles. That's 40. So about, what is it?
44.
Well, this would be 40. That would be 44, 48, 49. We could round it and call it about,
50 miles.
yeah, about 50 miles. Okay. So the cyclist rides at a constant speed of 15 miles an hour. So you would divide 50 by 15. And then you would have your answer. It says Jada finds a map and finds a note that says this map is not to scale. What do you think that means? Yeah.
It's not like a scale. It's not a scale copy or something. Like this.
Yeah, it's what it basically means. It's not accurate. There may be different measurements or different estimations you'd make. So let's say there's a city right here called Fresno. I'm just making that up, even though we have a Fresno here in California. And so let's say the measurement from here to here, what did we say it was? About 50 miles. And let's say that was accurate. But if I drew a line from Garden City to Fresno, And let's say, I'm going to guess, let's say it ended up being about 30 miles, when actually it was only 20 miles. The map was wrong. The map wasn't to scale. So some of the measurements on a map that's not to scale will be inaccurate. So go ahead.
So like anything that says it's not to scale, like it's not actually what it looks like.
Not so much what it looks like, it's just that it's you will not get consistent, accurate information off of it. All right. So here's the summary. Maps with scales are useful for making calculations involving speed, time, and distance. And they give you a nice example here. It says, here's a map of Alabama. And you can read through that. Okay. Then they've got a practice problem here. It says, here's a map that shows part of Texas and Oklahoma. About how far is it from Amarillo to Oklahoma City? Explain your reasoning. Well, you guys know what to do now. I mean, you can just take your piece of paper and then you could mark it right here. Here's 30, and then here's 60, and then just keep going. You move 60 over. This would be 120. And then you can figure out the distance between those 2 points and answer those questions. And that's it for lesson 8. Not much. So I'm going to jump to lesson 9. You can consider lesson 9 your Friday work. It says, without calculating here, this is page 75, and I only got about 4 minutes left. Without calculating, decide whether the quotient, and what's a quotient? It's a result or answer to a division question. Without calculating, decide which quotient is larger. See if you can do that without calculating. I mean, I look at this one right here, and what I first think about is how many times 11 does it fit into 23? Twice. Yes, it does. And then I think about 7. Does 7 fit into 13 twice? It does not. So that's one way to look at these, but just think about it, see if you can do that. All right, real quick, here's a rough sketch of Noah's bedroom. It's not a scale drawing. Turn the page to page 76, and here's what it is. It says Noah wants to create a floor plan that is a scale drawing. It says the actual length of a wall is 4 meters. So wall C is actually 4 meters. Mr. D. Woody, are you listening? Okay. All right. To represent wall C, Noah draws a segment 16 centimeters long. What scale is he using? Well, let me help you out with this. If it's 4 meters and how can I say this here? If the actual length is 4 meters and his scale drawing is 16 centimeters, that would mean that 4 centimeters equals 1 meter. Or the scale would be 4 to 1. Then it says, find another way to express the scale. Well, you could change the ratio, and we talked about this the other day. I gave you some examples, and actually, I think most of you gave me examples. If I said there was a ratio of 5 to 7, what's an equivalent ratio? Well, 10 to 14 would be an equivalent ratio. And you could do it this way. How about 15 to 21? That's also an equivalent ratio. So come up with another way to express the scale or the ratio. Number 3, discuss the thinking with your partner. I'm not worried about that. You guys can certainly work within your groups. Then it says the actual lengths of wall A. Oh my gosh, my time's almost up. So real quick here, they've got the lesson summary, and I'd like you to answer these questions here all the way to page, looks like 81.